Okay, hi. The timer, no timer, okay. I'll try to be on time. Welcome everyone to this talk on clicks to conversations, and I'm going to try to design with you some LLM-powered apps. Yeah, I've got the clock. So my name is Maria-Lise Blete. I work at Worldline. Do you know Worldline? Okay, not many. So even if you don't, you probably used our services today or yesterday or even the day before that. We are actually the leading company in payment in Europe. So every time you use your credit card, you are probably using our services without knowing it. And more specifically, I work in an R&D department, the labs department, and I'm in a team that is specialized in AI. I'm not a data scientist, as you can see. I'm a software engineer, but my colleagues are data scientists, and they have PhDs, they do patents, and that kind of thing. I also happen to have written a book on the subject. I have several copies with me. If you're interested, I can give you for free after the talk. Just meet me outside. So, do you guys know this guy? Yeah? Yeah, okay. So that's Steve Jobs, yes, with a computer mouse. And why am I showing you this picture? It's because there's this myth going around that says that when Steve Jobs visited the Palo Alto Research Center in 1979, he had this eureka moment when seeing the graphical user interface and the mouse, and this led to the first human-computer revolution, human-computer interaction revolution, where the mouse really played a pivotal role. Just to give credit where credit is due, that's the guy who invented the mouse, not Steve Jobs. So why am I showing you this? It's because I have heard recently, and I have seen on social media recently, that LLMs are the new mouse. The LLMs are the new revolution, today's revolution in the human-computer interaction. My idea in this talk is, okay, let's put that to the test. Just before we dive in, I need to make sure we're all on the same page, on the same level. So, this is a mouse. You can click it. And for large language models, well, you cannot click them, but they are they are a subfield of artificial intelligence. And their underlying principle is to generate the next probable word. I don't know if you write text or WhatsApp messages, your phone often predicts the next word that you're going to type. Well, LLMs, same thing, just much more powerful. So the mouse, you can click it, and the LLMs, you can have a conversation with it. Main big difference, LLMs are not deterministic by design. So even if you tweak the parameters of your LLM, you will never be sure that the answer will always be the same for the same input. So that's really something to have in mind. Really big difference with the mouse. You click it, usually you know what happens. For the mouse, my brand here is Cherry. I guess you have some others. For LLMs, well, you have two different flavors. Those which are closed, which you can only access through an API, such as Claude from Anthropic, OpenAI, and all the ChatGPT, GPT-4, GPT 3.5 models. Google Cloud, they have their Bard model. And there are other models that you need to run yourself, which are more or less open. I'm not going to go into details of that, but the idea is that you need to have your own servers to run them. And that's Falcon from the Technology Innovation Institute and the Llama series from Meta. Today I'm going to stick with OpenAI just because it's simpler for me. But what I'm going to show you, you can do it basically with any model. It will depend on the capabilities of the model, not on the API itself. So 5 concepts to get started. First one, models. That's one I think is okay. OpenAI has different models with different price points. Usually going with GPT 3.5 Turbo to start with is the best choice because it's 20 times cheaper than GPT-4. So yeah, let's start with this. And if you find it doesn't work, maybe switch to GPT-4. Next, prompts and completion. I'm guessing that's one word that you have heard, and context. So prompts, it's simply the inputs that you give your LLM, and the completion is the output that you get. For example, hello world, hello, how can I help you? If I have another question, what is Devox Belgium? I get this kind of answer. Now, what if I need to continue the conversation? Where is it located? That will not work like this, because the API is stateless. OpenAI does not store for you the conversation. What you need to do is send the whole conversation with all the messages and all the answers every time you want to continue a conversation. So it will look like this, and usually this is what we call the context. So the context is basically all the information that is fed to the LLM. Now, last one, tokens. So this is a completely random sentence. Tokens are, the LLM to process this sentence will split it into tokens, like this. So here, every word is a token except for word line, which is split in 2, and the period at the end. 1,000 tokens is about 750 words. And why am I talking to you about tokens? It's because it's the price points of the APIs. So, for example, with GPT 3.5 Turbo, this is the cost of this sentence. I'll let you count the zeros. So here is a hello world with the official library, the official Python library. I'm sorry. I have worked as a Java developer for more than 10 years, and I joined this AI team. And at first I was in denial. I tried sticking to Java, but it didn't work. I had to switch to Python. So yeah, now I'm working in Python. In French we say c'est la vie. But really I found that to interact with my data scientist colleagues and really be up to date with the latest frameworks and so on, I had to go with Python. So here's the hello world. It's fairly, you can understand it very easily. What's important is the messages. You see it's as a list, and you have a role and a content. And the answer will look like this. There's many information here, but the message, once again, for the answer will be like this: role, assistant, and content, the answer from the LLM. So the user is, well, the user, and the LLM has the role assistant. And then the messages continue like this in a list. So that was a bit long introduction, but now we're all set. Let's go to the problem statement. So like I said, I started as a Java developer, and my first project was a project for the French ministry, the vehicle registration system, which manages all registrations for cars, for trucks, for cranes, for everything that goes on the road in France. And well, this application, now I can say it, it's more than 10 years ago, was a nightmare. There were buttons everywhere, there were forms everywhere, and at one point we had more buttons to add, but there were no more room on the screen, so we added a pop-up, and things started to go astray from there, and we had pop-ups of pop-ups. Does that ring a bell to anyone? Did someone work like this? on a nightmare? Yeah, okay. Well, I'm sorry, I'm not going to solve your problems right now. I'm just going to create different ones. So my idea here was what I was saying earlier. I want to put the saying that the LLMs are the new revolution, human-computer revolution, to the tests. I want to rewrite this whole application as a chatbot. Okay, so I'm just going to turn it down a little because this was done by 20 developers for several years. I won't have the time to do all that in my free time. I sort of have a life, sort of. So let's imagine this system, a simpler system with 3 buttons where you can register, update, and delete a registration. And a registration has these 3 attributes, and every time you do an action, the user needs to confirm. That's the first my application where you need to click everywhere. Where I want to go is to this simple chatbots where I can converse. So we're going to go from clicks to conversations. So for this, I'm going to show you 3 different solutions, and we're going to start with the first one, of course. Very simple idea. I'm going to describe the whole application in one prompt. Imagine you have ChatGPT, you are talking to it, and the first thing that you do is give a very long prompt to describe everything, and then you chat it as if it's the assistant for the vehicle registration system. Now the question is, how do we design such a prompt? I'm going to use some prompt engineering tips. I'm going to divide my prompt into 4 parts. First one is easy, give some context. So you're an assistant, you can add things like you're helpful, you speak politely and things like that. Next, I'm going to set the output format. So that's actually the important part because I need to differentiate 2 types of outputs. For the user, which is the actual conversation, hello, give me more information, and the output for the application. The output for the application will be commands or ways to execute code, like execute register vehicle, and that's an actual Python code in the rest of my system. So what I want is something like this. I have the user input, and the AI output is split in 2. I chose to do this, to use a JSON format, so I'm going to ask the LLM to use this JSON format, where the output is the output for the user, and for the system, we'll need to use function and args. So this is the prompt. It's a bit long, but this is how I describe it. So I'm going to share my GitHub repository afterwards. You can. I'm not going to go in the details of the prompt because it's very long. But if you are interested, you will be able to look at it afterwards. Next, give precise instructions. So that's actually the biggest part. I really describe everything here. It did not fit on the screen, or it would be very, very small and not so interesting. And then last part, it's the off you go, but I still add another, remember, use JSON, because that's, if it forgets to use JSON, then my system will simply crash. So the conversations will look like this. The first one will be a role user content, and then the whole big prompt, and then my assistant will answer with my JSON format. Then the user will talk to it as the actual user, and so on and so on. And at the end, I will have my assistant call the function create registration, for example. And so every time we send a message to the API, we are going to send all the previous messages every time. Time for a demo. So let's hope. Okay, how can I switch? Yes, you can see that. Maybe zoom a little. No, wait. Okay, is it big enough? Yeah, okay. So I tried this with 3.5. It didn't work, so I'm going to switch to 4. And there. Python main, okay. Okay, good, I have internet. So here you have in white the actual conversation with the user, and in green it's the output, the raw output from the AI. So I'm going to say, hi, I have a new car. Okay, looks like it works. So I'm going to say it's okay, and 2015, and I'm going to forget my name on purpose. Great. My name is Blete. Yeah. Okay, sorry about that. My name is Blete. Now yes, okay, great. It asks for confirmation, and I'm saying yes. And yeah, okay, I have my first creation. So to be completely honest, this works not always. Sometimes if it gets the confirmation and so on, so we're lucky. Maybe I can delete one. Delete. And yeah, and there's no, so here, it's really, everything is mocked behind, there's no database or so on, it's really, everything is mocked. We're just testing the interaction with the LLM. So yes, great, it's asked for confirmation again, and yes, okay. So this is exactly what we're expecting, so that's perfect. Let's go back to, no, my presentation. So that was for solution 1. Okay, that was just in case I had some internet issues. So the issue with this solution is that it's not, well, I think you would agree with me that if I had a more complicated situation, well, I won't be able to do it in a big prompt, and it's difficult to be confident that the LLM will remember everything from the prompt. It's difficult to maintain and so on. What I would like to have is more control. It behaves like this. The solution 1 behaves like this. So I give all the instructions at the start, there's discussion, and then there's the action. What I would like would be something like this, where I can give small instructions, but at different moments, different steps of the process. The idea that I tried to put together here is a sort of state machine. So I have the user's input and the bot's outputs. I have the states, so a state will be a step in the process, and I'm going to create a transition function, like in a real state machine. And so this transition function will be given a state, a prompt, and the user's inputs. I will be able to go to another state with an output for the user. So if this doesn't make sense, I'll try to explain like this. I have my start step, and then the user will say, I want to create, I have a new car. The LLM with the transition function will detect that I have a new car, he needs to go to the new state. And then in the new states, until the user has given all the model, the user's name, and the year, we're going to stay in the new state. If everything is okay, we'll go to confirm, so the user can give confirmation. And yes, no, we go back, or we go to execute action. And we do the same for all the possible actions, new, edit, and delete. So the starting prompt will be much smaller. We have the same thing at the beginning. You're an assistant, and then same here, some instructions to have the correct outputs. I still need something in JSON, but it's a little different. I need a state and the output for the user. And the transition prompts will really have the intelligence of my system. So, for example, in the state new registration, the prompt will be like this. So I'm telling the LLM, you need the model of the car, the year, and the owner's name. To go to valid new registration, else you stay in new registration. Now, time for a demo. Okay. Okay, I'm going to zoom again. And this time, I can use 3.5. So that's the big difference between both approaches. So it's not 3.5, it's not perfect. The conversation is a little less smooth, but it works. Whereas for the first model, it's forgot about the JSON, it forgot real parts of the instructions. So Python main. Okay, is it big enough? Maybe, yeah. Okay. So okay, this time in white you have the conversation, and in green the states of my my diagram. So again, hi, I have a new car. Sure, okay. Again, I'm going to do the same thing. Okay, I did a typo. Okay, so here, so that where you see is that 3.5 is less intelligent than 4, because well, he understood that owner's name was missing, but it didn't really, yeah, it didn't act as accordingly. But because I have my state machine, I can tell it no, wrong name. Okay. So, yeah, so that's also nice with with LLMs. You do typos, they still understand. So the correct owner's name is the owner's name is Blete. Okay. Yes. Okay. I'm just. Yeah. Okay. We forgot about this. It's one typo, but that's fine. Okay. So. So it's very different approaches. It looks a bit the same, of course, as a chatbot, but it works. It works pretty well. So I'm not going to do the second step because I don't have that much time left. But once again, I'll give you the repository. So if you want to try it out yourself and have fun with it, you'll be able to. How do I go back to? Yes, great. So that was okay. Okay. So the advantages of this is that it's easier to introduce a more complex flow, and I can actually sort of separate the natural language processing from the rules. If I'm in a given state, I know that, my system knows that, and I can execute code, and I can really, it's easier to separate, you know, well, to use the LLM for what it does best and have the real intelligence done by code. Of course, it works with less powerful models, so that's nice. And actually, it's easier to validate. I can actually write some sort of unit tests to test my transition function. With the first solution, writing tests for the whole conversation will be more complicated. So, third solution. Why do I want to have a third solution? Well, because I have heard of agents. Have you already heard of agents? Yes, some of you. I see some heads nodding and others just going blank, but yeah. So agents are. What can agents do? They can perform actions upon the environment, and they can make observations and adjust their actions accordingly. So what is an agent? It's simply a piece of software where you can give it goals and you can give it abilities. So to do this, I'm going to use the LangChain framework. I'm not going to go into details about LangChain here because there are other talks at Devox on LangChain. I'm just going to explain how I'm using it. I'm going to give it goals. I do this by having a starting prompt where I tell him, okay, you're an assistant, do this and that. And then I give it abilities. To do that, in the LangChain framework, I use tools, and I create some tools. Tools converse with a human, and 3 tools to update, create, and delete a registration. For an example, this is how you create a tool in LangChain in Python. Sorry about that again. So here I link it to a function, create registration tool, which is an actual function that exists in my Python code. So this is some code that the LLM will be able to execute. I give it a name, and I give it a description that's a bit long, but that's on purpose. It's how the agent, how the LLM is going to understand how to use it and when to use it. So this description is extremely important, and I worked a lot on this description to make sure that the LLM understood how to use it. So last demo. Okay, so this one is a bit different. I need this. Okay. Zoom. Okay. This LangChain does absolutely not work with 3.5. It's too complicated. Using agents with 3.5, really, there's no hope there. So I'm going to switch the model, and once again, Python main. So this time, just so it's more clear, I did a small interface with Grado. So if you haven't heard of Grado, it's a simple framework for demos. Do not use it for anything else. But it's very great for demos, and 3 lines of code, I have this nice chatbot interface. So here I'm going to do the same thing. Hi, I have a new car. And you can see the agent thinking. So that's, I think, I really like agents just because of this wow effect, where you really, so that's the logs from, the verbose logs from LangChain, where you see the thoughts, sort of the agents. And I think it's pretty fascinating. So you have here, so that was the answer. Going to do the same thing once more. Okay, so it asks for my name. So you can see all the thoughts going on. Again, okay, confirm the okay, so, well, I want to confirm, but I don't know what I'm going to confirm, so little mishap here. Okay, I'm just going to say yes. I could say what details, I could continue, I don't have the time, but I know because we're dealing with LLMs and the whole conversation is sent back every time, the agent has the memory of the conversation, so I can, yeah, if it does things like that, I can actually ask questions and it will work. Okay, so I have the car. Now I'm going to update it. I want to update. Is that okay? I don't. Yeah. Okay. Well, that was not the correct registration number, but okay. I want to change the name. Yeah. So there's no backend, so I can whatever registration number works. I want to change that name to Smith. Okay, so I'm guessing yes. So that's correct. Yes, yes. Okay, and that was done. So yeah, that was it for the demonstrations. Agents are really powerful and really versatile. So let's go back here. Demo. Okay, that was in case it didn't work. So the results of this. I have 3 solutions, one being prompts, state machine, and agents. This one is good if you have a very simple use case. Actually, I would recommend to start with this one before trying something more complicated. This one is good if you have smaller models. It's a not so complicated use case. I think this one is very interesting because not all models, especially if you want to use open source models, for example, not all models work for. So state machine is an option, is a really interesting option to have in mind. And the agents, so they are very versatile and powerful, but they rely on a framework which evolves all the time. So it's very, very new LangChain, it changes all the time, so it's a bit difficult to use. And it needs a powerful model, and it will make make lots of calls to this model, so you really need to have a budget to use it. But I think it's fascinating. So now, okay, all these 3 were simple POCs, simple proofs of concepts. Now, what if I wanted to go to a real project? I'm going to share here some feedback, some tips, some tricks that we, as at my team at Worldline, that we have put together to face the issues. So the first issue is if you have worked with prompts, with LLMs, you know this feeling. Because every time you change a word, you change the order of the sentences, you add a comma somewhere, it changes the behavior of the whole system. And that can be extremely frustrating. What you can do for this is having prompt management tools. So there are many tools that are popping everywhere specifically for that. I cannot recommend one because it's all too new, but at least use Git to version your prompts and somehow keep track of what prompt is working and what was the results for this prompt, and so on. Issue number 2. So that's the biggest one. It's actually the real difference with my mouse here. When I have a solution with clicks and buttons, if the testers of my project run some tests and they say it works, well, it works usually. Most of the time, unless there's some things that they didn't. It's not a problem with the software. It's more of the coverage of the test. But yeah, so when we have a non-deterministic component, well, how can you do that? You can't, and that's a real shift in paradigm, a real shift in your mindset that you need to have when you're working with LLM-powered apps. What can you do instead? Well, you can prove that it should work most of the time. That's not perfect, but at least do that. So, like I said, test and prompt management, that's good. Having validation methods, just checking the outputs of the LLM just to not have this. I tested this, I can do this with my system, the first solution. If I say in the model is blue, the 4 wheels and the owner's name, it will say, okay, no problem. So add guardrails. So here I added some links for tips and tricks that can be useful. Next, add control loops. So what is a control loop? There's a pattern called chain of verification. The idea is to have a second LLM, a second model, or it can be the same, but a second call to a model that has a different role, and its role will be to be a sort of verifier and an inspector. So every time you ask your assistant to do something, you send the output from the assistant plus the instructions to the verifier, and the verifier will check if this was correct. So this has been proven to work very well with smaller, especially with smaller models. It's something that is very useful globally. If you're interested in LLMs, everything that starts with chain of, like chain of thoughts, chain of verification, and so on, these work well for smaller models, and they try to reduce the hallucination aspect. And to do this, you can use the sequential chain of LangChain. Next, so you have proven that it should work, but if it doesn't, you need to have a fallback solution. So of course, handle errors gracefully, add a retry, alternatives, and so on. For the retry, I actually had some, I think it was in the second solution, I had a retry here, especially, maybe it was the first one, I don't remember. For the JSON aspects, sometimes my model just forgot about it, and so I asked it to retry. Very simple, so that's their better, more intelligent way to do this, but this worked. So retry can be nice. And third thing that you should do is monitor and evaluate. So that's very important. Log your queries, collect the user's feedback, and you can also add an evaluation loop. So it's the same idea as the control loop, except that you do that at the end to monitor your model. OpenAI has actually some tool called evals that you can look up, which really help for this. So that was for issue number 2. It's for me really the biggest one. Issue number 3, prompt injection. So this is a screenshot from Bing. You might have seen it on social media. So someone managed to to send a malicious prompt to Bing, and Bing revealed all its internal secrets. You know, it had a code name called code name Sydney that was not supposed to disclose. Well, it did, and so on. On my side, I tried this on so that was for the agent solution. So I told it to behave as Yoda. It worked. It did behave as Yoda, but it was Yoda for registration, for the vehicle registration system. So why not? And on Twitter, I asked someone, maybe he's in the room, to try to give me a prompt to try this out, and it worked also. So here, with this prompt, my LLM, my agent, did reveal that it had 3 primary tools, and I think you could go on and it would spill everything. Actually, there's a paper that you can look up, and they have managed very easily for all the known LLMs to make them destroy humanity. So yeah, so if all the well-known LLMs can do that, well, yeah, yours probably will too. So how can you manage that? I see 2 risks. The first one is to reveal internals, like, you know, my code name is Sydney, or I have 3 tools. You have to see if that's an issue or not. For me, revealing it has 3 tools, it's not an issue. Revealing code name is Sydney, well, why give it a code name? I don't know. Maybe the real solution for this one is simply in the prompt, do not give anything that you don't want it to disclose. That's actually very easy. And the second risk was to change its behavior, like Yoda, or making it give a plan to destroy humanity. That's, well, what you need to do here is make sure, especially if your system is interacting with, especially if the LLM is interacting with your system, make sure that the LLM does not have access to restricted functions or functions that need some authorization, or that it simply cannot, even if it wanted to, delete the whole database. That's something that's important. And secondly, I'm not a legal expert, but perhaps have a disclaimer somewhere. I'm not responsible if someone destroys humanity with my bots. What you can also do is add checks in the user inputs and at the AI outputs. For example, you can validate the format and length of the inputs. If you know in your chatbots that the user does not need a whole paragraph to talk to the chatbots, then don't let it have a whole paragraph, because the longer the space is, the longer the prompt can be, and it's more likely to have a malicious prompt that works. You can also analyze intent. That's once again sending the prompt to another model, maybe the same or another one. You can use, for example, the moderation model from OpenAI, just to check that what is the intent of this prompt. Is it really correct? Is it really related to the vehicle registration system? And once again, monitor and audits. I think that's very, very important. Issue number 4. Since the beginning here, I sort of, it looked like everything was free. I did not really care about costs. I can actually show you how much. So this is here. Zoom in a little. I think I called it costs. Yes, I can show you what costs what we did just now. So this is all the calls I did to the OpenAI API. You can see. So that's the first line. So the first table is all the costs all the calls one by one, and at the end, it's a comparison between the three solutions. So solution 2 is much cheaper, but we did one thing less than. One step less than the other two, but still it's much cheaper. And solution 3 was so same model, did the same thing, exact same thing, same model, but it's about twice the cost. Sorry, I need to go back here now. Okay. So what you can do to limit the cost, of course, limit conversation length. Don't let the user talk too much, and there's some tricks like summarizing the conversation and user cache. And then all the tips that I gave you for issues 2 and 3 included more calls to the LLM. So of course there's a balance here of how much money you're willing to spend versus what are the risks that you're willing to take regarding prompt injection, regarding hallucinations, and so on. And then there's issue number 5. I actually have lied to you since the beginning, because this whole project is a really, really bad idea. Do you know why? Because we're sending personal data to OpenAI. And I don't have a contract with them. I'm using the public API. I don't have the enterprise version and so on. So we're sending very personal data here. So yeah, I really recommend, before using any solution, look at what are the conditions are, what they do with your data, and so on. As a conclusion, it looks easy because we are all used to ChatGPT and how smooth it is, but it's actually very challenging. So we were lucky because all my demonstrations worked, but I can promise you, when I tried it, it was not always the case. And there's really the all 5 issues that I gave you are actually big issues, difficult to solve. The landscape is very rapidly evolving. Frameworks are changing all the time. It's very difficult to keep up. There's actually new models everywhere. And globally, the feeling I have, it's still in sandbox phase. I don't feel that all of this is completely ready for production right now. Maybe in a couple of months, But right now, I feel it's very difficult to have something stable and that really works perfectly. What I have heard on social media is that many companies jumped on the, okay, we want our own chatbots, and then they rolled back because they realized that some users had received completely wrong answers, and that had a huge negative impact for the company. So be careful, but I think it's definitely promising, and really we can have fun with it, and I'm sure we can make some great applications with it. I'd like to add a quote from Yann Lequin. I like his quotes on Twitter because he's really, he really on the point, and he has really strong opinions. And usually what he says over and over is that LLMs are stupid. So it's very different from what the keynote we had yesterday, saying that LLMs are the new, we have reached AGI. Here he says, no, they're stupid. and the plans to destroy humanity won't work, so that's good news. But really, so here, for me, that's interesting. And the conclusion here is that LLMs are tools, actually just like a mouse here. And really, it's up to us to make something smart of it. If you have questions, well, you can follow me here. You have once more the link for the GitHub if you're interested. And I have 4 minutes for questions, if there are any. Yes?
Have you also tried to use local LLMs with this app?
Have I tried to use local LLMs? So with these tests, I have not. Some people on my team are using Llama, for example. They have had good results. Some people on another team have used a model, but I cannot remember its name. It was just less powerful, and they have used many techniques like chain of thoughts, tree of thoughts, and this chain of verification, and it really was, it gives some really promising results. And I think I saw a hand here.
How does it react if there's an exception raised in the backend?
How does it react if there's an exception raised in the backend? It crashes. No, yeah, here in these, so the 3 procs that I showed you here are very basic. Well, if there's an exception in the backend, it will need to be handled in the backend. It won't go back to the front end, to my LLM. If there's an exception in the LLM, for example, the LLM forgets the JSON part, then that's something that is very important to handle. So the rest of the application does not crash. Okay. Well, thank you, everyone. And if you're interested for the books, just meet me outside.